But before we get to questions, let's have your presentation, Brad and Scott.
Right, pleasure to be here, folks. Scott and I got a bit of a presentation to walk through. I'm just going to try while I'm sharing this, get this up on the screen. Uh, we, for those that don't know, are Essential Energy. We are the distributor of poles and wires in regional New South Wales. We cover 95% of regional New South Wales, and our interests in energy resources is to help our customer base get the best value out of their investments as much as possible, because that's in the interests of regional communities. And effectively, we see that happening as local communities invest in renewable energy resources. Less and less is being drawn from the transmission network, and more of energy is being distributed using our network to your neighbour. And that's a great outcome in terms of reducing the costs of energy transmission, but also reducing losses and valuing the local energy that's generated, and using it more locally. So hopefully we can get a share up here on the screen. Is everybody seeing this little slide here?
Yep.
All right, first technical hurdle has been overcome. So what we thought we'd do today, for those that didn't join the call a little bit earlier, is sometimes we do virtual tours and we walk around, and I got some feedback from my last tour that I did this on was that people started to feel a little bit seasick. So we thought for this one, we'd take some images of what we've got here, and more than happy to do a walk around should there be questions later on. We didn't want to make people feel a bit ill. That was really the reason for it. So let's see if I can advance on the slide here. It was going to play the game. Give me a second. Sorry, folks. Okay, so I'll get started to talk about what Nexus is.
Yep. So what we have here is we were trying to understand, or what we're trying to do is understand where we think customers are going to be within the next 5 years, 5 to 10 years. So we built this lab, installing what we could get our hands on of the time. So everything in this lab here is connected to the Wi-Fi. So light fittings, we'll go through all the other bits and pieces, I guess, in the next slides.
Yeah, a few more, yeah.
Yeah, but everything in here is connected to the internet. It all gets enrolled in an application in Home Assistant, and then we can look to try and optimize. But yeah, everything is connected, and it's all readily available today. So lights, we're
No
trying to work on
slides,
it.
fellas.
Sorry?
No slides,
Shane, they're just going through the slides slowly at the moment, Shane. Oh, can't you
Yeah, we
see
can't
them?
see 'em. No.
Sometimes if you click on a little thing with the slides, it becomes a big thing. So you need to go up to your grid view or your views to see them.
We're currently on a slide that's called What is Nexus, for those folks that are wondering what slide we're currently on. And it's got 4 images of the lab facility here on it.
So I'll just explain out those images that you can see there. So on the left-hand side, you can see we've got a whole panel with a lot of inverters on there. So one of the parts of the lab here is we try and make sure that the equipment that's getting installed on our network is actually safe and is going to operate the way that we think it should. CEC have done a test, or they've done confirmation that the bit of paper that's been submitted for their listing lines up with what the checklist is, where we go one step further and do actual testing.
And the next image that's in the lineup here is effectively an image from where Scotty and I are actually sitting at the moment, looking down into the lab. So we have 2 shipping containers in the lab here. The first image is of the first shipping container, which is to my right here. And then this side of the lab is another shipping container that's set up like a home. And so don't let appearances deceive you. It might look like a shipping container, but it actually is a home. And then immediately behind us, the third image is our laundry area, just in case you're wondering. And then there's an outside image for where we test vehicles for vehicle to grid. So to give you sort of a bit of an overview of the layout of the lab and how we've tried to make it look like a home, and in fact, it functions just like a home, and then we can mimic particular behavioral outcomes.
So
So
you
Viva?
bring your laundry from home and you're cooking from home and really use those
We
appliances?
Yeah, I could. However, I don't think anyone wants to walk into the lab and see my undies hanging up. So, yeah, we do have some rags that we quite often just repeat the same test on.
Yeah, we have done a couple of real washes here
We
for
have.
some stuff, but yes, apparently Scotty's underpants are not an appropriate adornment of the lab, for those that are wondering about that. All right, we'll keep moving then. So look, this is just a infographic about how we split the assets up in the lab and how we treat them, and we'll talk a little bit more about this later on. But probably what I'll draw your attention to is the sort of the orange table down the bottom there. And we've sort of classified assets into when we say assets, appliances, into areas where we can do certain things with them. And some of it might not be the way that we traditionally look at appliances or lights. You want to talk to some of these, Scotty?
Yeah. So with this, you can see there that we've got our flexible loads, our throttleable loads, and others. So, in effect, most people don't really care that when their dishes get washed, they just want them clean. Most people don't care when their water gets heated, they just want it hot. So these things, so that ability where they don't care when it happens is obviously classed as like a deferrable load and allows us to schedule that when it best suits the household, not just doing it when we're available to press the button. So that's our flexibility that we've been given with Home Assistant.
Maybe we talk to some appliances and sort of give you a bit more of a picture of this. But really, this is, like I said, an overview of how we've treated assets. And some of them we've treated, appliances, we've treated them in a non-conventional sense. And we'll talk to that in particular about the fridge. I think that's probably a good example.
So one of the things that we've done here, we've been able to do is, so we have a standard fridge. This fridge has got Wi-Fi capabilities. And in the past, I'm guessing majority of people have gone, why would you want Wi-Fi capabilities in a fridge? Like turning the temperature up and down remotely is probably not too important. But with that little functionality, we've been able to turn the fridge into a battery. So when we have extra energy, so when the energy is cheap or we have an abundance from our roof, we turn the freezer section down. So the way a fridge freezer works is the compressor works only to cool the freezer section. So all that energy that comes from the network is used to freeze your goods. Then to cool your fridge section, it's a circulation fan that just takes the colder air from your freezer and moves it up into your fridge. So if we're able to run that freezer section down to a lower temperature, so when we've got an abundance of energy, we turn it down to negative 24 degrees. So we have 6 degrees worth of extra thermal mass. And then when it's expensive, we're able to turn the temperature setting back to negative 18. And we have 6 degrees worth of thermal mass stored in all our goods to get us through that peak event.
And probably pick up on some of the questions that came through around, particularly around electric vehicles. So in this infographic, you can see we've got an electric vehicle that's a charge. So it's a flexible charge outcome. When's the best time to charge? It automatically does that the way we've designed the system. And then also vehicle to grid, which is a combination of overcoming the household load to get to exporting from the grid. And we dispatch that in the right price signaling. We'll show this in detail a little bit further on. We'll go through a couple of the assets next, I think. Scotty's already talked to this. Probably the thing here you can see is the way that we're operating this fridge. We're operating within the safe food zone, right? So it doesn't matter. Well, Scotty complains about over hard ice cream, but
ice cream eaters won't like it.
Yeah,
but everyone else won't mind.
Yeah. So really, the idea here is that becomes a battery. It means for you to store energy in it and at the right time. So when we've got lots of solar, we maximize the self-consumption that drives that freezer temperature load. The compressor doesn't come on until it hits minus 18 degrees Celsius. So therefore, we've avoided using energy when it might not be the most optimum time to do so.
So hot water system, very similar to the fridge, in the way that you can choose. You don't care when it actually heats. You just care that it's hot. So we can schedule that to be a way of storing energy around the house. So when we have that abundance of energy or it's cheap on the network, we can choose to turn that on and store all that energy within our hot water system as hot water.
So talked to this one already. I can't show the actual dryer here. So for folks that might want us to show the dryer, unfortunately, this dryer, it met its end of life. It's no longer functional. So we're going to get a new one. But the premise is exactly the same. For this particular dryer, when it was working up until last week, we were able to schedule this thing automatically when it was best suited for maximizing our self-consumption here in the lab. Again, this was a Wi-Fi no one. Scott's mentioned Wi-Fi. We actually don't care what protocol assets talk. We'll make it work. And that's a really important aspect of people thinking they've got to go out and buy new assets to get things working. That's not necessarily the case. So the hot water system that mentioned before, we've got a device that allows that to talk. Scotty will go grab one now so you can see what that looks like. It doesn't mean we have to upgrade it. That hot water system doesn't come out of the box with communications protocols.
So it can just be a plug style connector. You can see these, you can get them from Bunnings. So it can turn any load that doesn't have a switch that you have to press start. You can then control it. So simple pumps, pool pumps is a good one. That's how we control all our pool pumps. Like I said, Bunnings, or you can buy Ogham Ray is the way it's said, isn't it? I always get fluffed up with the way that this is pronounced, but yeah, so it's a Shelley product, allows you to connect up your hot water system they're on, they cost around the $50, get them wired up, and you can run up to 25 amps through those devices.
So that's how we control the hot water system, and for legacy assets or legacy appliances where it makes no sense to change them out. We'll talk about that shortly. We use those plug style devices or other means of communicating with them. The washing machine's exactly the same as the dishwasher. It just turns on when we need it to turn on, so it's preloaded. Now, probably another thing too, people say, oh, you guys are doing a lot of right down to the nth detail. We absolutely are, because for some people this will make sense, for some people it won't. There is a point where you go, okay, I've achieved the outcome I want, which is usually controlling things like your hot water loads and your major load appliances. You don't need to go to the depth of detail that we do here. Like we individually control all the lights that are on our ceiling here, and there's what, 20 of them, Scotty?
Yep.
Thereabouts. That might not be what you want. The purpose of our lab facility here is to show what the art of the possible could be, but not necessarily that everybody should do this.
To Brad's point too, we're not doing it with things that are super expensive. Like we are trying to do it the same way that customers would do it. So these are lights all come from Audi. So buying them from the supermarket, very cheap. I think they're $13 each. So it's what's available, what we think everyone will use, and we're trying to do it in a way that, people will actually utilize.
It's a really good point about the cost to do this, and it's something we normally do on a tour. You probably picked up from some of the images already. We're not operating in some flash building. We're operating in some shipping containers. We make these things work at the lowest cost price point possible. So our full fit out costs for this side of the lab, which is the home, and that's a fridge, a dishwasher, a washing machine, the dryer, a TV, which we have on the far end, and what else do we have in
Pool.
the pool as well.
Yeah. So pool pump.
$1,500.
Yeah, it was just a smidge under $2,000.
Yeah. So I'll keep moving. The pool.
There's our pool.
It's quite obviously a pool for those that haven't quite picked up on that. But you can see in the image there's the pool pump on the floor, and it just well, Scotty, you talk about this one.
Yeah. So it's just a pool pump on the. We don't actually need a pool. I'd love one, but we don't have the budget. So yeah, I tried to think of how we could represent a pool as cheaply as possible, and this is the way they've done it. So it is still the same hardware. It is still a pool pump. It is still pushing, moving water around. So in essence, it is a pool.
And it's a dumb pool pump. So
Correct.
the plug point that Scott showed before, that's how we control this particular asset. Dishwasher. This is a retrofit. So the first dishwasher we bought was a Wi-Fi enabled dishwasher. And then some staff in the depot here, their dishwasher, which is this one, was playing up a bit. And we thought, well, we'd be kind and we'd give them the Wi-Fi one because we wanted to do a little bit of an experiment. Could we automate this dishwasher? Now, again, we're not recommending this as a normal practice for everybody, but there will be some people out there that will go, oh, I could do that to my dishwasher. Scott, do you want to talk about what we've done to this thing?
Yes. Excuse me. So we were able to use some Arduino products, so a very cheap little PC for around $45 with a set of relays to, excuse me, break into, so add additional control to a dumb dishwasher, and converted it. We used a grad to help this, so we had a business degree grad come through for a week. I think no, he come through for a little while, but within a week he had this. So someone who had no tech skills whatsoever was able to research, understand, and install and turn a dumb dishwasher smart, which is now brought into our Home Assistant platform.
And our line crews that had a relatively difficult dishwasher because the handle's broken on this one are quite happy because they've got a brand new one and we've got this old clunker, which works perfectly fine for our needs. Air conditioning in the lab. So we'll talk a little bit more about this, but we turn the lab, even though it's not the best thermally insulated building, into a thermal battery. And doing that allows us to maximize our efficiency of our solar generation so that we thermally chill or heat the lab facility based around our excess solar. Now, obviously, there's a comfort level issue to this. If we're in the lab and it's really chilling the lab because it's cheap and accessible, that's not the best outcome. So it does this when we're not in the lab. All right, a couple of quick images of inside and out, just so you can see it. We've already seen on the other photos an image of the inverter testing side of the lab, and then I just took a quick image this morning of what's outside. So you can see the two shipping containers there, and we've got an EV parked up there at the moment, which we're testing. We'll actually run a demo today with this particular EV for you folks today. Scott, did you want to add anything about the inverter side of the lab?
No, if at the end, if you just want to know more details on what we do for the inverter testing, we're happy to jump into detail now, but save boring everyone that may not be interested in inverter testing. So we picked up from the questions, there's a lot of questions around vehicle to grid. We'll address what we can here today. But we'll start first with where we've been on the vehicle to grid journey. So April last year, we announced Australia's first, what we call CCS2, which is a type of plug, vehicle to grid solution that is network connectable. And that's the image you can see up on the right-hand side there, the SIG Energy system. So we helped co-develop that system. You can get this across Australia now, and every DNSP or every network service provider allows you to connect this system up to the network. Now, our partners for this one were CSIRO, SIG, and AusEV. AusEV, unfortunately, has gone into receivership. They are remanufacturing the Ford F-150 for Australian conditions. Ford stopped manufacturing the electric F-150. As a result, they no longer are a functioning business. But that's where we started 18 months ago, a bit more than that, to build out a capability. And that showed the first solution, and this was a warranted solution, I might add too. AusEV were warranting the vehicle to grid outcomes here. That's not the case for any other OEM or any other vehicle manufacturers in Australia at the moment. We're working towards what's the next iteration of this particular vehicle to grid outcome. But just want to make the point, so there's some questions in there. Can you connect vehicle to grid to the network? Absolutely you can. Every jurisdiction, as far as I'm aware of, in Australia is allowing this particular connection.
Then there's two others that are available as well, that are standalone solutions. Your problem, as it has been since the start of this, is vehicle warranty. Now, Scott and I both do vehicle to grid at home, and the way we manage our warranty might be the way that some people want to think about it later, but we won't go into details on that today. This is just more to show you how we built the capability here. And you can see in the middle screen there, we're discharging 2.8 kilowatts. Scott, you want to add to this slide?
No, I think you've covered it all.
So that brings us to a live demonstration of Nexus. I've got one or maybe two slides just to quickly show here, and then we'll go live. Just for under the bonnet, what are we using here to do this with? And Scotty's already mentioned this already. We're using an open source product called Home Assistant. Now, we're not using the native Home Assistant. When I say the native, just out of the box stuff, there's a whole pile of add-ons and additions that we've made to Home Assistant. They're all open source. They're all available on GitHub. You could do this at home. It is, without question, Angie Nerdland.
Yeah.
You're gonna need a lot of work to do this, but
Which is probably what we've got on the line here anyway.
Yeah,
we've got very interested parties.
So what we'll show you today isn't what you'll get out of it, just a straight download of a Home Assistant baseline installation. You have to add componentry to it to make it do what it wants to, what we've done here. But it is achievable. We have at least 4 people we know that have effectively picked up the lab implementation here and replicated it at their house. One in Queensland in particular, who's done a sterling job of doing this exact same thing in his own home.
Yep.
Excuse me, folks, I'm going to have to swap screens. So while we're doing that, Scott's going to fill in with some chat while I get this up for us.
Yeah, so I guess I can cover a little bit more on the V2G and the warranty outputs, I guess, and it all comes down to individuals, the amount of risk that they're willing to accept. If they've got a car that's no longer warranted, then it's a no-brainer. This is something that you do. But yeah, there is some different ways to think about it, like that what they allow with their current discharging of the battery. They allow you to use the car in a V to L sense. So be able to use the car's onboard inverter, allow it to discharge at 3.6 kilowatts, which is most cars. So they're allowing you to do that. They haven't set any requirements on the amount you can do that. It's just open. And then the other thing is that most OEMs, I haven't seen any OEMs actually put pen to paper and say that you're not allowed to do V2G or you can do V2G. They're still leaving it very ambiguous. So that's probably what I would say on that. Brad's got the demo up now.
Thanks for filling the time, mate.
Yeah. Thanks.
So, folks, what you're seeing here is the dashboard of the lab, and we'll walk through and explain what's going on here. It is a complicated system, and we probably won't be able to answer everybody's questions today on how we've done this, but if we can give you an overview at least, it might prompt some thinking. So up here is our current buy and sell prices at the moment.
So I'll put an artificial price in. So
this is adjusted price, but normally this is looking at the wholesale spot price. For those that aren't familiar with the way the markets work in Australia, we have an Angie market. It's based on kilowatts, and its price point is derived every 5 minutes. So we get a price feed from 2 sources. One's the Australian Energy Market Operator's forward forecast price feed, and then another one from a particular retailer that we get a price feed for. That's one of the inputs into this product outcome here. Then what you're seeing over here is sort of in the middle, and it's got minus $46 on it. That's what it's going to cost us to run the lab for the next 3 days, is the dispatch schedule of the lab for the next 3 days. So you can see the purple bar here. That's a vehicle to grid session that'll probably kick in. What are we looking at, Scotty?
What's it now?
Yeah, no, the one that's scheduled. Something about 5 or 7 o'clock tonight, maybe?
Yep.
Yeah, they're about 7 o'clock tonight, based on a forward forecasted price.
This you can show that down.
Yeah, we'll show that in a minute. This is optimizing every 5 minutes as well. So every 5 minutes, it's calculating out what's the best thing to do. So normally at this time of the day with our solar, it'd be going, the best thing to do is to charge your car and your stationary battery and turn on other assets like the fridge or heat the hot water system. We've been a bit naughty and we've said, look, thanks so much for all your optimization. That's great. We're going to do vehicle to grid because we want to do a demonstration today. Scott, do you want to explain the circles here, what's going on there?
Yeah, so you can see from those circles where, let me point the little cursor. So you can see over here to the left-hand side, you can see where the energy originates. Please ignore this one little one. It is a bug in the system and we just can't clean it up. It's the SIG energy product and it reverses value. So it just flows the wrong way. But please accept that it is actually discharging at a rate of 6 kilowatts right now. And you can see that it's going to the grid along with some of our other batteries, air dispatch batteries with me. So I've given it a false indication. I've told it's worth $3 at the moment and it's going, hell, let's sell everything and make some money. Hence you can see right there that we're doing this. So we've got our batteries. So that's another 8 kilowatt battery within the site. And you can see the other. So we've got our 24 kilowatts of solar on the roof. You can see what our fridge is currently doing. And then some of the lab devices.
So I'll scroll over to the bit on the left-hand side here. Sorry, right-hand side. You can see there's our price forward forecast. And that's being used. And then there's some controls. So we can override what the system is doing. So we can put it in a maximum self-consumption mode. We can put it in a maximum financial opportunity mode. We can force it to do a discharge, which is what we're doing now. So you can see vehicle to grids live. Off that vehicle I showed you before, we're discharging that car at 6 kilowatts. Or I could say, no, I really want to charge the car right now. Happy days, and it will do so.
Might do it while you're talking.
Yeah, so Scotty's just going to do a bit of a change on another screen for us while we're talking through this. I'll scroll down a little bit further so you can see what's going on here. This stuff that I'm just scrolling through at the bottom, you can just see that. That's the forward forecast of dispatch of items within the lab, our price point, and what our return will be, and why it's doing it, what's the mode it's in. So you can see doing this particular bit here, battery charging, it's in maximum self-consumption mode when it's doing that. And it's doing, like I said, every 5 minutes, it works this out. The way that we also look at this is we also go, okay, we know we've got a certain amount of solar. So I'm going to reflect over to our input screen here and explain this. This is our solar forecast. So people on the call may be familiar, you get a solar forecast from the Bureau of Meteorology, which is the Australian solar forecast. That's really great if you're Australia-wide, but we're in Port Macquarie here. And so what we've done, and we've gone and grabbed the Bureau of Meteorology's solar irradiance forecast for Port Macquarie. And we use that to forward forecast out our solar pattern. Now, keep in mind, this is a test facility. Things go on and off all the time. We're running tests. So sometimes life doesn't match reality, or prediction doesn't match reality because we've turned things on and off. But I'll draw your attention to this part of the chart here. The blue line, you can see, I've just got to get out of the way here, is the forecast. So you can see it's sort of like stepping up as it forecasts out. The yellow is the actuals. And it's pretty good. More than enough for us to figure out what we might want to dispatch and or charge using our solar energy in advance of time. And the closer we get to dispatch, the better the forecasting gets. This is what's called, this is using well, for those that are really interested, it's using a linear forecast, so a linear optimization algorithm to predict out what it will do and how it will dispatch accordingly. I'll pull up the deferrable loads and get Scotty to talk through this one. In particular, the fridge one's the good one to talk through.
Yeah, so you can see. Yeah, so you can see the rate. Yep.
I was going to interrupt back on just to clarify on the forecast. You're putting into your forecast, you're looking forward maybe 24 hours and you're
3 days.
3 days, and you're putting into the forecast some pricing information, some solar information from outside, And how much are you putting in around the loads and what you need to try and run over the next 3 days? Like, do you have, I'm going to be a typical household for the next 3 days, and so I'm going to want to do all these things. Are you forecasting every single one of your flexible loads and managing them all in that sort of
That's a really good
algorithm?
question. We're running the house just like you would normally run a house. There's no, you can't open the fridge door between 10 and 9 sort of thing. It's literally as you would run a real house. So when the fridge needs to cool, it will cool. And it will then pick the most optimal source to cool, the cheapest outcome to cool. Same with the hot water system. So we're not saying you must have your showers between 6 and 7 because that's the cheapest outcome. We're saying have your shower when you want your shower, and the hot water system will pick when it needs to heat what the cheapest outcome is, or our algorithm will dispatch accordingly.
It will see your uses, and it'll start to predict out what your use is going to be as well.
Yeah, but we're not
Sorry
forcing
to
them.
interrupt, but yeah, I just
Yeah,
thought we'd
it's
get
a
a bit more
really
clarity there.
no, it's a really good point around. We're not forcing behavioral outcomes here because that's not how any of us live our lives. We want to live our lives the way that we live them. We're saying in the system's unaware of your behavior, but in the fact that you're interacting with your fridge and your hot water system, it goes, well, okay, it needs to do something now in terms of heating it up. What's the best thing for it to do? That's how it sort of works. There is a third feed in here on the inputs, which we're not showing today, but is what is the network availability? So poles and wires and conductors have certain amount of capability and capacity in them. And that changes depending on what people are doing. If they're putting a lot of load onto the network, that changes their capacity. If they're putting a lot of solar energy back on the network, that's changing its capacity. And if we don't manage that right, you end up over-investing in the network. It's a really bad outcome for everybody involved. Hence another reason why Essential Energy, as a business, we're really interested in helping customers maximize their self-consumption, because if we can do that, it avoids excess solar on the network at peak times and means that we don't have to invest in a lot of network for a short period of time. I'll flick back to the discretionary load just so Scotty can talk through how the fridge is working.
Yeah. So we'll just quickly go through the fridge, and then I think we might open it up for some questions. I know I promised half an hour and I've gone over a little bit. So look, you can see there, you can see the width, the band width for the cycles of the compressor. You can see that they lengthen out between 8 and 9, and that's where that the peak period would have happened. And then we had an abundance of solar, so it's tried to cool the fridge down through that area. So try to absorb or store more energy within that fridge there.
And I know you folks are into sustainability and just thinking about this from an asset, from a appliance life perspective. If you've got a freezer at home and its set point is, say, minus 16 degrees Celsius, it's driving your compressor on and off a lot more harder. So what we do, we turn the compressor on and it stays on till it reaches minus 26, then it just switches off. So it's not hunting around that temperature gradient. So in some regards, this could be a better outcome for this appliance. Can't promise that. We're not sure, but it's a likely outcome. I might flick back to the main screen now, and we'll hand back to you for questions. Scott, do you want to reset the price?
Yes,
We'll reset the price back to the real world, and you can see the system respond in real time, and you'll see it starting to change energy flows. Over to you guys for questions.
Excellent. So everyone, please type your questions in the chat. I have a ton here, so I am going to kick off. And one of the questions that we do have already is about how you're using Home Assistant for monitoring and control. So Jerry, please put more questions if you don't think you got enough, if you want to make that a more specific question. So I want to stick with the fridge. Obviously, the lifetime of the fridge is a relevant consideration. We all hope you're managing the fridge better. The design of the fridge is important to understand when you put in the control part of that equation. do you think your way of controlling the fridge externally is a really sound way, or there might be other ways to design a flexible fridge? But also, my real question is, how do you make this sort of long-term change so that all the fridges can be controlled, and this is the obvious way to do it in the market, and we make sure that ultimately there's an incentive for the fridge manufacturers to give us smart fridges that are cheap to run because they make the most of their thermal load.
Let me mean and address the last question first and leave the first question to Scotty, because the first question is around, there are options. The last question is where are appliance manufacturers at? And look, there is definitely moving in this space. So in 2023, Samsung said any appliance that they manufacture with a price point of $50 US or above will come Wi-Fi enabled, and they are starting to arrive in Australia. So that is the pathway. Now, when we say Wi-Fi enabled, and we have skimmed over a lot of detail here today, folks, and apologies for that, the protocol that matters here is actually called Matter. So you want to look at a Matter-enabled product potentially for a really long-term solution, but in the immediate term, Wi-Fi-enabled products will get you to where we're talking about, and a lot of manufacturers are moving that way. Bosch has just recently done it. LG's got their Smart Things style outcome to do some of this stuff with as well. And it will get into the Australian market. We went and bought this fridge. How much did it cost us, Scotty?
It was just over 1,000.
Yeah. And so that's a reasonable price point. If you're starting out in life, you're fitting out your house, that's an affordable price for a fridge that's Wi-Fi enabled. Second part of the question is Scotty.
Yeah, so I'll go back to the way that we're managing it. Do we think it's decent, and do we think that the manufacturers would object to how we're dealing with it? Well, we're operating within its mechanisms. We're not changing any range. So this is the range that you could cycle it to. So if you had the choice and you wanted to, you could just walk up to the fridge and turn it down to negative 24 degrees. So the freezer sections, you could turn down to negative 12. So we're working within the operating range that's been set out by the manufacturer. So I don't think there would be any issues there. I think it is being, as Brad said, it is being nicer. It is, yes, running them longer in duration, but it's giving them a better off cycle, and it's less frequent starting. So that's when any motor is going to wear out, is going to be on the starting.
And look, the reason why I think that last question to Scott, that question to Scotty, was not, apart from just being mean, Scotty's actually a refrigeration qualified technician, so he knows a little bit of what he's talking about here.
I'll save one of my questions about skills, but think about that. We've got some discussion about the vehicle to grid and the battery to grid, and Graham's pointed out that on the customers on Amber maybe aren't even making enough to cover their subscription. So how much money are you making? And can I add John's question, will vehicle to grid save the grid or remain a niche part of the NEM? I'm skeptical about V2G because I think you get most of the benefit by charging at the right time. And so that sort of smart charging 1.0 rather than vehicle to grid 2.0 sort of thing.
Great. I'll ask a question and I'll see if I can get some reactions for everyone on the line today. Can you please thumbs up or thumbs down? What are you looking to do? So if you're thumbs up, if you're looking to make money and you're wanting to actively try and pursue money, so an income, financial advantage from doing this, or if you're just wanting to have self-reliance and you're just wanting to have a zero power bill. So if we can get some thumbs up, thumbs down. So thumbs up if you're trying to make money, thumbs down if you just want to be neutral. So, and then so from the other side, so from your question in relation to making money, if you come up with the right strategy, look, there are places like Amber where you can try and play that market. But ultimately, you're either going to become a full-time employee of your own system to try and maximize it, so you spend a hell of a lot of time doing it, or you're going to hand that trust over to a retailer. Now, I probably shouldn't say, but I'm not fully trusting of retailers. I don't think that they've got our best interest at heart. That's just my opinion. I would rather control the system myself and make sure it's going to work for my own benefits.
I want to pick up on the value proposition, and this is an unfortunate reality of standardization of terminology. So people refer to vehicle to grid, but really to get to vehicle to grid, you've got to overcome the household load, as we hopefully showed today. So we had a standing load of about 2 kilowatts here in the lab, and the vehicle had to supply that 2 kilowatts before it could even get to the grid. So the bankable value every day for the vehicle grid technology is vehicle to home. And you can bank that as an immediate cost saving every day. So the realities here are for people that don't have stationary batteries, and I want to refer to the population of regional New South Wales, 25% of regional New South Wales rents. If we can enable vehicle to grid, then they have access to charging at the right time at a lower price point and discharging to meet their home loads to minimize energy costs. And so that's why we feel, and look, there's a debatable question about whether it'll scale or not, but we feel that that's the opportunity. A quarter of the population in regional New South Wales, this might be the only way they can get a part of the renewable energy transition. And it's even worse in metro areas. About 31% of people rent in metro areas. The battery rebate schemes and solar schemes are all tied to a premise. If you're a renter, it's really hard to access that.
Yeah.
And part of the reason why we've been really focused on vehicle to grid technology in Australia, in essential energy, is because the more you can get value out of your EV purchase, the better. And the quicker that happens, the better. It's now mostly cheaper to buy a vehicle with a battery in it than it is to put a stationary battery in place, albeit the rebate scheme significantly altered that economics. That rebate scheme has an expiry date, and vehicle prices for EVs are going down. So will it scale? We don't know. We think there's opportunity, and we're prepared to invest to show that opportunity outcome. And it might be 10 years away. I neglected to mention at the start of this call that we're innovation and essentially. So our remit is to look 5 to 10 years out. And so the question might not be, will it scale now? But there's a lot of work to be done yet before vehicle to grid can scale. We didn't talk about protocols. The current protocol that we're using to do vehicle to grid with probably is going to be difficult to get it outside of a residential arena. It's probably the point. We can take those sort of questions offline later on. Has that addressed that question?
So there is the point, and you touched on it as well there, Brad. Graham's made the point that, we don't want to become energy traders, but a lot of us want to use our assets to offset the cost of our assets. So we might have to do a little bit at the most, valuable times. On the vehicle to grid idea, can you expand on whether other systems beyond SIG Energy are being developed that we should look at? And secondly, you talked about vehicle to load. How much are you looking at the resilience equation here and, your SAP setup, what happens when there's an outage? I mean, I know you work for Essential Energy, but sometimes there are outages. So those are my, let's stay on the vehicle to grid theme.
I'll talk about the outage one. I'll let Scotty handle the first question.
She's got me all stirred up now. What can you just repeat the first part of the question?
The
other charges.
Other charges.
Energy,
Yeah, sorry.
So there's B to G options.
There are other CEC listed charges. So there are charges that have got through the process and that are available to install at most on most networks, I believe.
Yeah, that's right.
So Star Charge would be one of them. There's InfiPower. They've got through.
Vehicle to grid. That's right.
And they got through.
Yeah, it's the same. It's a
okay. Yeah. So there's another 3. Now, all I would say is when you're looking at when you're looking at it, you need to make sure that you understand how they operate, and you need to understand who's going to operate it. So this is my own advice, and yeah, take it or leave it, I guess. But if you understand how you want to use your car, you're probably going to want to be able to follow your own load within your own home, because you're not wanting to, just like the majority of the people here, they're not going to want to be energy traders and push an abundance of power back to the network. It's about covering that V to H, covering their own home, so that way they're not drawing from the network. And when the opportunity is available, push back a little bit of power to cover their daily connection fees. I'm guessing that's majority of people. He's just trying to get there, and then if there's a little bit more cream, then good to go. But it's not about trying to make hundreds of dollars a day.
I want to pick up on that point too. With the current protocol that is used for vehicle to grid in all the products that are available on the market, it's what's called a modified protocol. So it's effectively a non-standard approach to doing vehicle to grid. Now, the reason why we've done so much testing with the products that we've had through the lab here is to try and make sure that they're reliable and safe. But with this current protocol, it's really important to understand the vehicle and charger combination, because in almost all instances, the vehicle is usually unaware of a vehicle to grid session. It thinks it's in a charging session. There is a protocol that we're working on that will allow vehicle to grid to scale. I don't want to get too much of the technical details here. That protocol was released in 2022. We're working in Essential Energy to try and bring that to speed in Australia, but it needs the vehicles to be updated as well. So probably at the moment it really is a consumer beware of what you're buying and understand its behavioural outcomes with the solutions that you're putting together. So you're fully aware of your situation, because note before, at the moment, no OEM is warranting vehicle to grid. Okay, no vehicle OEM is warranting vehicle to grid, and there's certain ways that Scotty mentioned before that would mitigate that risk, but at the moment, it is consumers' decisions to be made here. I want to address the outage part, because it is a really good observation around the realities of the network that Essential Energy runs. For context, we run Australia's biggest dispersed network. We have the lowest customer density in Australia. So we have 1.4 million poles, 185,000 kilometres of overhead line, and a customer density of just shy of 4 customers per kilometre. To try and build a network that is resilient to all the outages would be an enormous burden on an already expensive network, because there's a lot of assets. So we've invested in standalone power supply systems, and that is available in some of those systems going out there, and really there for people that are on really, really long feeders with lots and lots of assets into their sole customer. The work we're doing here in the innovation part of the business and what we're showing today would help us to right size those standalone power supply systems. In conjunction with that is some work around, if we can get vehicle to grid to scale correctly, it provides a resilience outcome alongside what you would need as a gateway. So the native vehicle to grid stuff that we showed you today needs to be coupled with a gateway device so that it can stand up a part or a house in the event of an outage. There is certainly some people out in the media saying, oh, vehicle to grid is going to work and stop outages. No, you need another bit of hardware. Or you need to buy some hardware that will go off grid in the event of the network dropping out. So just another little bit of information there that most people are unaware of.
And just to add, Tom here has said with his vehicle to load, which you mentioned earlier, is often the onboard inverter in the car, and it's only a couple of kilowatts. He's had to do a separate circuit. So
yes,
there's these huge limitations on vehicle to load being your keep me running during an outage solution, because it's not delivering enough energy into the house.
absolutely. So if we think about particularly the regional areas in New South Wales and the recurrent events that we've had. So we did some analysis work in Essential Energy, and over the last 24 months, as presented recently at a conference, we had a major event every 2 weeks. We've never seen anything like it. It's just astounding. It's went from floods and fires and major storms. And when we say major storms, it's areas of the network that are really impacted. We see vehicle to grid as providing a community resilience outcome once we overcome this new protocol challenge. And we think that that might be a way where we can provide support to a community hub while that community recovers from that natural disaster.
So while we're on the last question on vehicle to grid, John asked, how has your attitude changed since you started this project? So you would have had a view on vehicle to grid before you actually got in and played with it. What do you think its prospects are now that you've done a lot of work on it? Better, worse than when you
We
started?
both do it at home. Does that answer the question? But our use
But so you're joining the bandwagon and you think it's going to fly.
well, our use cases are different.
I do V to G pretty much every night. So mine is always about it's my battery size isn't big enough. It isn't quite big enough to cover my consumption. So I do use my car, and I don't pull much out of it. It is at a very slow rate, but it is enough to keep me going and extend me to get me through the next day. So that way I have zero importing from the grid during nighttime hours. Obviously, I draw from the grid. There's obviously retail plans out there at the moment that you can draw free energy or energy off the grid for free, and I take advantage of that and I charge my cars, charge my batteries. Yeah. Then that allows me to have a pretty close to neutral power bill, if not making a little bit of money.
And my use case is somewhat similar, but I don't do it every night. I do it for when I want it, or when there might be an opportunity for me to go, "Oh, okay, I can export some energy to the network for financial opportunity." But most of the time, mine is vehicle to home to support my home usage. Reflecting back on what did we think before we started on this adventure, we didn't really know how we were going to start with this. It was a challenge because this as a product really didn't exist when we first started this outcome in Australia. So
the Leaf was available. The Leaf was what we started with.
Yeah, we did start with the Leaf, but in terms of a scalable outcome and one that we could see happening in the real world, we didn't have a view, but we could certainly see the opportunity of releasing and democratizing energy more, because and that is really probably the key point. When we get vehicle to grid working, people have choice, more choice than what they have today, and particularly for those that are renting.
Can I get you guys to stop sharing your screen so we can all see each other a little bit better? So we've got just 5 minutes to finish up with. I would like to ask a question about dreads. So in the dreads demand response enablement, perhaps, I'm not sure exactly what it stands for, but in the appliance manufacturing space, we now have the system being able to send control signals to inverters. We've talked about air conditioners being able to be turned down and things like that through this massive standards-based system. How does your project or the lab and that sort of standard systematic stuff, how do they come together here?
Yeah, you can. Okay, so for context, Dreads came out of Queensland, and I'm actually ex-Ergon Energy when that was first brought in. And it's a four-stage approach, effectively. So if you think about maturity technology, we've gone from basically on-off to more of a scaled thing with Dreads to what we showed you today, which is a dynamic ramped outcome depending on needs with multiple inputs and the like. The work that we do informs interoperability standards that are coming out over the next 5 to 10 years' time. So the realities are that the standards approaches are evolving, like standards should evolve. And the work that we do in conjunction with a range of other people, like there's a lot of really excellent work overseas in this space that are informing international standards that, generally speaking, Australia will adopt. The nature of standards is they are slow.
you want to bring backstop in as well?
Yeah.
I'm guessing you're talking about with backstop as well, not just thread functionality.
Well,
Yeah.
that there's a conversation to have there, but you can't do a lot of things like load shedding and what have you until you enable homes. So
Yeah.
and Graham's got a question about community microgrids here. Well, community microgrids can't be scaled properly unless you can turn off your non-essential loads or something like that. So there's a whole lot of stuff wrapped up in the question of what we can control and how we go about controlling it.
Absolutely. And look, there's no getting around the fact that the communications infrastructure is absolutely critical to making this enablement work. But then I would layer on top of that, and again, we probably get into detail on that today, but the cybersecurity outcomes are as equally important in order to make sure that the systems are secure from threat actors. And that those two things go hand in hand. The comms and what we call the public key infrastructure for cyber will be the absolute foundational requirement for things like microgrids, because otherwise you could have threat actors really destroying the networks and destroying community resilience outcomes. There is a lot of work going on in those spaces. We've leveraged our local Wi-Fi here, but there's no getting around the fact that public communications and communication systems will require hardening in order for us to get to where we need to go to at a national level.
I'm going to squeeze in one last question before we wrap up. Dennis has asked, how advanced is the gateway device to enable this residence? And I'd just like to add on that, can you also talk about skills? Because you're a refrigeration engineer, I'm an electrical engineer, but you've managed to do all of this stuff that's IT sort of skill based. So I'd just like to understand a bit more about, I don't even know what a gateway device is. So how you've managed to
Show
pull that
one.
all
We'll show you
together.
one.
Folks, I hope you don't get seasick, but we're just about to walk you out to show you a gateway device, which is available on
Gateway
the market.
device that enables this residence. So this is where all the smarts come in, is it?
Yep. So this is the SIG Energy product, and this is their gateway. So what they allow is you will have, so from your residence, I'll just quickly talk through how it's actually physically connected at a normal. So in the test facility here, it's not the same because we have safety as number one principle. So everything has interlocked and we do it slightly different here. But generally, you would have, power would come into your property, it would go through your fuses, it would go through your meter, and then it would come into this grid port. So from this grid port, then you would wire back from, it would go into the gateway, back from the backup port would go into your home's circuits. So that way so in between these two devices, there is a contactor up here. That contactor is what allows you to connect to the network and disconnect from the network. Then from there, you have the ability to put in some different gateways, but you might have two or three different inverter configurations. So if you have an old system, a new system, you want to bring them in, you can bring up to two. And then you've got in this gateway, it gives you the ability to control another circuit. So there's another contactor in here that can control just the one circuit through the gateway. So if you had a very big load, this one allows up to 125 amps per phase to be switched in and out.
And there are other gateway products available on the market that are coming out there. So have a look at when you look at your solar systems or your inverters, there are certainly products out there that are coming. Does that help with the gateway conversation? So basically, we can take this lab off grid almost instantaneously. Well, it is instantaneous, you don't even notice the flicker. And if the network goes down, the same deal. I want to pick up on, I think of the
Sorry,
skills.
just to interrupt quickly, is it agnostic to whether it's single phase and three phase or
Just a different bit of hardware there. So the gateway is different. It's obviously there's no point putting three-phase contactors and circuit breakers in a single-phase install. So they just have a different product. That is a single-phase product and a three-phase product.
And they're relatively cheap. Like prices are always relative to what your means are, but that's what $1,500, is it?
Yeah, around there.
That particular price point. Pick on your schools. conversation. That is a really, really good observation. And one of the reasons why the energy transition requires a multidisciplinary approach. We've done all of the coding ourselves, but we've used an open source product. So we've leveraged a global community of hackers. Shout out to the hackers. They've been awesome. Whenever we've had a problem, we've been able to go to a global community of people that have got an interest in this area and write some code to deliver the outcome. The transition, and it hopefully picked up the level of complexity today that we're looking at. It's enormous. Australia needs to build up skills. Essential Energy has started to look at this, and there's a training academy proposed to be built at Tamworth to help fill some of these gaps, but it is a long road to go. Our hope in innovation, Essential Energy, is like we've built a proof of concept here. We hope to educate the market and people about this so that there is available products that are a little bit easier to use than what we've shown you today.
That's a good point. There are products out there that you don't have to get this detailed in. Like we were at a conference yesterday and we found probably 3 or 4 different inverter manufacturers that actually started to think about controlling loads in the house. So you don't have to go down this way. You can subscribe to those products and you can have, you know, your major loads. You don't worry about the little loads anymore. You get all the big ticket items. And they're available today, and a lot more are starting to think that way.
But I think it's a very astute observation around the skills requirements here, and particularly now we've got 2 sectors effectively merging together. We've got transport and electricity merging into one sector, and what does that do from a sovereignty risk? What does that do from an economic foundation risk? So we would argue that the services it essentially provides to regional New South Wales economically underpin regional New South Wales. Without electricity, there's no economy. But then if you add in electrical transport, what does that happen? And what's the requirements there for grid security outcomes in order to make sure that our communities stay economically viable? Really big challenges. So whilst we've talked about the technology challenge today, there's the economic challenge. It's a really big multidisciplinary thing to consider.
Absolutely. Well, that has been the most fantastic webinar. I'm sure everyone on the call will agree. A nice message here from Helen Ross saying, thanks for bringing so much technology back to language even I could understand. So, you know, you've done a really good bridging the gap between super nerds and the rest of us job. So thanks again so much, Brad and Scott, and thank you everyone for joining us. Stay tuned for some of our upcoming webinars.